So in the last two videos, I talked about the Pythagorean theorem and special right triangles. And what I neglected to say is that this unit is all on trigonometry, and trigonometry is simply the study of right triangles. So you'll see a lot of right triangles in this unit because that's what trig is. So I don't want you to be intimidated by the word trigonometry. It's just right triangles, which we've been working with before. All right, I want you to now pause the video so you can read this description, and then I want to talk more about it. Okay, so now that you've read this, I really wanted you to see where these special ratios are coming from. So they really did look at these patterns that they were seeing. Like if these are similar triangles, they noticed that 31 degrees was always across from this ratio of 3 to 5, this over this. Okay, so that idea is where we're going to get all of these ratios today. Okay, so some background. If I have the same angle, so notice that these are all similar triangles with the same angle, 20 degrees, and I look at this side, okay, we're going to call that the opposite leg. Okay, so the side across from 20 is opposite because it's opposite across from the 20. And the side right here, this is called the adjacent side because it's right next to it. Adjacent means right next to. And then of course, we have the hypotenuse of a right triangle always. That's across from the 90-degree angle. So you'll hear me saying opposite, adjacent, and hypotenuse, and that's what we mean because they were studying the same angle and the ratio of those sides. So we want to just have some terminology to talk about those. All right, so in a right triangle, we have these opposite, adjacent, and hypotenuse. And notice that you always have to have an angle that you're referring to. The right triangle, the right angle in the right triangle will always just be that. We know it's 90 degrees. The two acute angles, though, can be lots of different possibilities. So if I'm talking about this angle, this little angle A, or the side A, is the opposite of that angle. Notice that if I were to change which angle I was talking about, if I was doing B, this is no longer the opposite side, that is the adjacent side. So you really need to be careful using adjacent and opposite. It depends on which angle you are referring to. Okay, so we have different ratios that they have found patterns to. The first ratio we call sine. Okay, on your calculators, it will just be abbreviated with SIN. And that is going to be the length of the opposite side over the hypotenuse. Okay, so A over C. When we have another ratio, cosine, that's abbreviated with COS on your calculators. All right, that is going to be the adjacent leg over the hypotenuse. And then tangent, that's the one we were just looking at in that example that you read. That is going to be the opposite leg over the adjacent leg. Okay, so that'll be abbreviated with TAN. All right, so when you read even the abbreviations, please use sine, cosine, and tangents. Okay? Now, what does that mean? Well, we've got, okay, some more abbreviations. So the sine of whatever angle we're using, this is the Greek letter theta. Okay, so we'll use theta quite a bit instead of angle A or something like that. So sine of theta is opposite over hypotenuse. So OPP is opposite, HYP is abbreviated for hypotenuse. Okay, so here I want you to think sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. These abbreviations, SOHCAHTOA, is what we're going to use as a mnemonic device to help us remember these ratios. Okay, so SOHCAHTOA. So if I say, all right, think about your SOHCAHTOA, then I'm talking about all three of these different ratios. The ones underneath it, these are simply the reciprocals of them. Okay, so if I wanted to do the reciprocal of opposite over hypotenuse, that's just hypotenuse over opposite, and we call that, this is cosecant. That's how you say that. the reciprocal of cosine is secant. Okay, so that's the reciprocal of that. And then we have the reciprocal of tangent is cotangent. Okay, so SOHCAHTOA is all you really need, and then these bottom three, you know, are just the reciprocals of those. All right, so there's your SOHCAHTOA. Just another graphic for you to remember. Sine, the SOH, and then CAH, and then TOA. That's your SOHCAHTOA. So how do we use those? Well, here's what we can say. If I'm looking at the angle A, so notice in our directions, find the sine of A, cosine of A, tangent of A. All right, and then we'll get to the B's. We're also going to do the same thing for the B's. All right, so if I'm looking at angle A, I would probably mark that first just so you remember. So we can write all the different ratios for these angles. So first of all, I'm going to fill in the third side of the right triangle. How do we do that? Remember Pythagorean theorem. Or if you recognize this as a triple, you know that that should be 12. Okay, so this side right here is 12. All right, so sine. Sine is opposite over hypotenuse. So according to this angle, the side across from that is that side, and the hypotenuse is this side. So when I write my sine ratio, that would be 5/13. Then if I do cosine, that's adjacent over hypotenuse, so ka. All right, so adjacent side is the 12, and then the hypotenuse is the 13. And then tangent is TOA, so O opposite over adjacent, so that would be the 5/12. Okay, so here we're just purely identifying the different ratios we have with this angle in this triangle. Okay, so now let's do B, angle B. So I'm going to relabel my triangle now. 12 is still there. 12 is true no matter which angle I'm using. But now when I label my adjacent and opposite, that will be different. So opposite of B is the 12, and adjacent is the 5. Okay, this is still the hypotenuse. All right, so for sine of B, sine is opposite over hypotenuse, so that will be 12/13. Cosine, that's adjacent over hypotenuse, that will be 5/13. And then tangent is TOA, opposite over adjacent, so that will be 12/5. So notice that the fractions, the ratios are different because we have a different angle, and that makes sense, right? You change the angle, the ratios are also going to change. All right, so let's move on. Here I want you to use your calculator. So what the calculator has done is all these mathematicians that have found these ratios, they kept track of them and recorded them. And used to, before we had calculators, we would consult a chart and look at that chart of recorded values. Well, all the calculator does is it has those recorded values ready to pull up. Okay, so get your calculator out and I'll show you how to do that. So on most calculators, if you go to your mode or your settings, you should have something that says degrees, radians, and you want to make sure you're always in degrees since these are degrees. Radians will be next year when you do Algebra 2 Trig. Okay, so if you're in degrees, that's great. You can get out of your menu or settings. So all you have to do is find your sine button. It should say SIN, so you should be able to type in sine of 10. So mine opens up a parenthesis, and then you're just going to type in 10. You won't have to put in the degree symbol. And when you press enter, you should get some long decimal. So mine gives me 0.173648178. Okay, obviously we're not going to record all of those every single time, but let's just to be consistent, let's make sure we're always doing at least 2 numbers after the decimal. Okay, so sine, we'll say sine of 10 degrees is approximately equal to 0.17. Okay, so now do cosine of 38 in your calculator. If you do that, you should get 0.78, and mine has 88, so I would round that to 0.79. Okay, and again, those are approximately. These are decimals. Whenever we're rounding, we're doing an approximation. And then tangent of 44, I got 0.965, which rounds up to be 0.97. Okay, so that's how you use your calculator. So those are those stored values. Okay, so then how do we use that? Well, if I have a triangle and I only know one side, we can't use Pythagorean theorem. And now I don't have a special angle anymore. Before we had 45, 45, and 30, 60, 90, and I would be able to find the other sides. But now I've got 40 degrees. So these stored values in my calculator will help me solve this. So if we do one thing at a time, so I'm going to find the x first. So x, according to this 40 degrees, is the hypotenuse. The y is the opposite side, and 8 is the adjacent side. Okay, I have to use the only side they gave me, which is 8. So I have to use adjacent. And if I'm trying to find x, then I have to use hypotenuse. So which one of those in SOHCAHTOA uses both adjacent and hypotenuse? Correct answer, the cosine. So that tells me that I have to do the cosine of 40 degrees. And when I do that, I should get a ratio that is the adjacent side, which is 8, over the hypotenuse side, which is x. We don't know that. Okay, so how does this help us? Well, the cosine of 40 I can find using my calculator. So that's what you're going to do right now, is do cosine of 40, and that will be 0.766. I'm not going to round that yet, so don't round yet. And that equals 8 over x. Okay. Now this is a fraction equal to some number. So what I would do is, just for argument's sake, and for visual sake probably, put that decimal that you have in your calculator over 1. Now if we had a fraction equal to a fraction, what would you do? You would cross multiply, right? So I would have 8 equals this 0.766, 766x. And then how would I solve for x? I would divide by the 0.766. All right, so you can do 8 divided by your answer. And if you don't know how to get just your answer on your calculator, ask me in class and I'll show you. So I'm getting approximately 10.44. So I'm going to round to 2 decimal places. So I know that the x side of that triangle is 10.44 approximately. Okay, so now what if I was doing y? Okay, so if I was doing y, then I have to use the side that I was given, which is 8, the adjacent side, and the opposite side. So which one uses both opposite and adjacent? TOA, tangent. Okay, so I'm going to go down here. I'm going to say tangent of my 40 degrees is equal to opposite over adjacent. Okay, let me scroll back up there so you can see. So tangent of this 40 is opposite over adjacent. So that's going to be y over 8. Okay, so I'm going to do tangent of 40, which is 0.839. I'm not going to round that yet, so don't round yet. It's just I'm recording it for right now. Put that over 1, and I'm going to cross multiply. So I'm going to do y equals 8 times 0.839. So when I'm typing this into my calculator, I'm just typing 8 times my answer, which is approximately 6.71. Here's where I'm rounding. Okay? So see if you can try this other one on your own. Pause the video right now and see if you can set up for X and set up for Y and solve. So here are the answers I got for X and Y. You can pause the video right now and see how I set it up. If you got the right answers, then move on. If you didn't, go back and check your setup, check your decimals, and make sure you didn't round or type it in wrong. So how do we use this? Well, this is used all the time in word problems in real life when we want to find a missing length or a missing angle. So two vocabulary words I need you to be familiar with is angle of elevation and angle of depression. So angle of elevation is when someone is, if they're looking straight out and they tilt their head upwards to look at something, that angle that they tilt their head is that angle of elevation. Okay, so how much did I elevate my chin? All right, that's your angle of elevation. Whereas angle of depression is if someone's up here on higher ground, okay? If they look straight out, that's the horizontal. But then if they have to tilt their head downward to look at something, that is the angle of depression, okay? So these angles are the angles of elevation, angle of depression. Now, if you notice that these horizontal lines, they have to be parallel, because true horizontal, we're assuming, you know, that we're on flat ground, that'll be parallel to the ground, all right? So your horizontal line of sight will be parallel to everyone else's horizontal line of sight. All right, so these angles are actually alternate interior angles and will always be congruent. Okay, so keep that in mind. All right, so angle of elevation, angle of depression. Let's do one word problem that uses those. All right, so we have Chinese legend from the Han Dynasty. So he flew a kite over the palace of his enemy to determine the distance between his troops and the palace. So if the general let out 800 meters of string and the kite was flying at 35 degree angle of elevation, how far away was the palace from the general's position? Okay, so I'm assuming that when he's flying, he had this kite tied to the ground or something, because they didn't tell us how tall he was. So if he was flying it like, you know, standing up and flying it, they would have to tell us his height. But let's say we've got this, and we have this kite. Okay, so here's the general. Here's the kite. And so he waited until the kite was all the way on top of what was his enemy, right? Or the palace. Okay. So if he's with his troops, and then here's the palace, we'll call that P. Okay, and then the kite is right above it. Okay, straight above it. All right, so you see how we've created this right triangle from these three positions: the kite's position, the general's position, and the palace's position. Okay, so there's your right triangle. That allows you to know you can use right triangle trig. All right, and then he says that the angle of elevation, which means it's from horizontal going to the diagonal, that is 35 degrees. So he used some instrument to measure that. And then he let out 800 meters of string. So he was able to measure how much string he let out. That was 800 meters. So he wants to know how far away is he from how far away are the troops from the palace? Okay, so this is the value that we want. Okay, so you see how we just made a right triangle and set it up, and we introduced a variable for what we want. And now this looks like a problem that we just talked about. Okay, so let's label some things. Here's our angle, 35 degrees. All right, X is the adjacent side. This side is the opposite, and this is the hypotenuse. We have to use the 800, and we're trying to find the adjacent. So we are going to be using from SOHCAHTOA we want the one that uses both the adjacent and the hypotenuse, which is the cosine. So we know we're going to be doing cosine of our angle, which is 35 degrees, and that should equal adjacent over hypotenuse, which is x over 800. All right, so now we're going to type that in. Cosine of 35, I'm getting around 0.819. Remember, don't round yet. And then cross multiply. So I'm going to have x is equal to 800 times that decimal. And if I do that on my calculator, I get about 655.32. All right, so this is roughly 655.32 meters away from the palace.